All right, so this is the newly recorded part 2 of chapter 3. So I apologize, I'm not exactly sure what happened, but a few slides of my lecture did disappear in the version I posted. So let's return back to the question that I asked you all at the end of part 1. So at the end of part 1, I asked you all to think about the traits and preferences that would be favorable during the pandemic. And obviously there's really no right or wrong answer here because we don't know. We would need to actually see how this plays out long term. But the things I instantly thought of, so I know that there's been some kind of preliminary research coming out that there are particular biological characteristics that might help someone recover faster from the COVID-19 virus, or potentially make them less likely to get sick. So I know, I think it was like 2 months into the pandemic, there was some conversation circulating that maybe people with a particular blood type would be more immune. I'm not exactly sure where the research stands on that. It's probably a little too preliminary to conclude that blood type matters. But if it does, that would potentially be one thing that, if the pandemic lasts for many generations, then we would probably see the human species kind of converge towards one or maybe two types of blood type rather than the diversity we see now. I've also heard some people suggesting that men maybe fare worse if they actually do get the virus. So it's possible that people that are biologically female would have an advantage. Of course, then we would need to take into consideration procreation for the species. Again, I think it's too early really to come to any conclusions, but that would be something that I would be interested to see if it played out long term. And then also thinking about more of the challenges we're facing. So there's a lot of social isolation. People are on their own. So I would think that people that maybe are more comfortable or maybe even thrive in social isolation, they would probably do better long term. People that have better coping strategies are going to do better long term. So those were just some of the things that I thought of. Again, there is no really right or wrong answer to that question, just kind of food for thought. So one of the most important things from this chapter, and the reason I wanted to add these lecture slides, heritability is kind of the main point here. So we're talking about the proportion to total variance in a trait that is attributed to genetic variation within a group. It's a lot of words. I know that definition is confusing. So I just wanted to kind of put my own spin on it. And again, that's why I posted these updated PowerPoint slides. So again, I apologize that there were some tech issues with the first version. So essentially, heritability boils down to how heritable is it? How genetic is the trait? What percentage of the variance that we see in that trait can be attributed to genetic variation within the population? So there's a few important things to know. So this is typically presented as like a proportion, so like 60 out of 100, which could also be translated to 0.6. So the closer this ratio is to 100, or the closer this number is to 1, it is more genetic, meaning less of the variation can be attributed to environment. So when we see something like height, I think when you look around your biological family, you probably see very similar heights among people, particularly within the same gender groups, and so that is a highly heritable trait. Something like table manners, low heritability, and so there's a wide range in between these different characteristics. And so this is a whole line of research, is trying to determine how genetic something is. So these are kind of the important need to know facts about heritability. So an estimate of heritability only applies to a particular group in a particular environment. That's because when we start to look at other aspects or other things that can influence our traits and our attributes and who we become, environment does play a role. And so if we're looking at, let's say, a group of students that has very similar socioeconomic background, then differences between those kids, it's going to be more likely due to heritability or genetics. Whereas if you have a group of kids that have a lot of different resource opportunities, some kids are high socioeconomic status, some are low, some have tutors, some don't. So if we were to estimate a heritability rate or heritability coefficient in that population, it's probably going to look a little different than if we estimate it in the group that has similar backgrounds. So it only applies to a particular environment, particular situation. To me, the most important thing to remember, because students most often confuse this, is that heritability doesn't apply to the person. It's within the population or within the group. So that means, for example, if you know that both of your parents have Alzheimer's or some disorder or condition that we know is highly genetic, it doesn't mean you're necessarily going to have that condition later in life. Yes, your chances are high, but heritability estimates don't actually apply down to the individual level. It's variation within a group. We also know that even things that are highly heritable can be modified by the environment. So that's another important thing you should take away from this lecture, is that nothing is 100% genetic. And so I know in the first version of this lecture, which will now be part 3, I talk about twin research, but I never really talked about adopted children research. Again, I'm not totally I'm not totally convinced that I understand what happened tech-wise. But so in addition to the twin research, we can also compute heritability with adopted children, because adopted children present this kind of unique situation where they're going to share an environment with their adoptive parents, but they're going to share genetics with their biological parents. And so this creates kind of a natural experiment, because if they're more similar to their biological parents, then we're going to understand that the trait or characteristic or attribute is more genetic. Whereas if they share more commonalities with their adoptive parents, we're going to know it's more about the shared environment. And so researchers can actually use these designs in studies to calculate a heritability estimate, and that's where a lot of our understandings of genetics have come from. And I know I talked about this in the now part 3, so I won't go into this. But again, just to kind of highlight that in addition to doing research with adopted children, we also are able to compare identical and fraternal twins to then calculate heritability. So go ahead, and this is where the new part 3 picks up. So this is where you would have continued in the prior version. So again, I apologize for the tech issues. Not sure what happened. Please, if this ever happens again, let me know. I feel bad that you all had a few days where you're not really sure what was going on with the PowerPoint slide. So please always reach out, ask me a question, and I can investigate and try to fix it or help you understand, what the material is that's posted. So have a great day.